start working with trig identities. Okay. Once again, as I talked about yesterday, this is probably the most challenging part of trigonometry is dealing with trig identities. It's one of those things where some people, the first time you deal with trig identities, as you're going to sit there and try to do some last night, it will be a struggle. If it's not a struggle, good for you. Okay, but if you struggled through trying to get through some of the problems last night, it's okay. It is one of those things where the first time you go through trig identities, it is once again a challenge. But as you go along, it will start to get better because we will go through problems here today. We will go through problems tomorrow that will hopefully help you and assist you in regards to dealing with the trig identities. Okay, so if you felt completely lost last night, you look at them, you try to get the stuff down, you go, I don't know. That is a natural thing. But as we go through some problems today, hopefully things will start to click a little bit better for you and get a little bit better in regards to getting through the trig identities. My suggestion to you is always mathematically, they are going to either ask you to add, subtract, multiply, or divide things a lot of times. So do that. Add things, multiply them, FOIL them out if you need to. Okay? Do the process that they're doing or they're asking you to do there. Okay, we went through some ideas yesterday in regards to how we can approach trig identities and what you should look for a little bit, what you should be looking at, and what hopefully you worked on a little bit last night is you worked on, you'll be able to utilize a cheat sheet. So you need to get down on there these trig identities so you don't have to put those things in memorization. Okay. Hopefully the thing is as you go through this, the more you use what we are dealing with here, the more it will come a little bit more natural to you and you'll start remembering it. Okay. You just have to make an effort and you have to push yourself through some of the problems. For example, you had the odds on page 111, 112. You think, all right, I got the odds. We all know the odds in math problems are in the back of the book. Okay, so you start looking at the back of the book, and of course, the back of the book says answers are contained within the problem, and there's no solutions there for you. Okay, so you have to just sort of try to fend yourself through the problems. Bless you. For example, problem number 13. If you look at 13, it has we have 1 plus sine of b over 1 minus sine of b. We want this to look like cosine squared of b. Now, these exercises are not for me to show that I know how to do the problems here. Okay, these are exercises that you can utilize to be able to work yourself through it, and I will help guide yourself through it, help guide you through it. But the problem is you need to get experience at doing some of these problems. So you need to be doing the work and sitting there and going through Sandlot learning. Okay, Sandlot learning is not, you're not going to learn anything. And Sandlot learning, once again, is, oh yeah, that's how you do that. Yeah, that's how you, I got it now. Mr. Gregg, I got it now. And you don't write anything down. That's what I call Sandlot learning. Okay, Sandlot learning doesn't work. Okay, this tells us on the right-hand side, you have two things that are being multiplied together. Okay, well, what you had to revert this back to is, well, if you're in algebra, In an algebra, they ask you to FOIL out 1 plus x times 1 minus x. FOIL it out. Well, rather than having x in there, throw the sign of b in there. So FOIL it out. Go first, outer, inner, last. You have 4 terms there. FOIL it out. FOIL it out. Once again, I'm not tapping on anything trigonometry-wise here. What I'm tapping on is algebraic skills, which I will revert and I like to go back to in regards to doing these problems. Is I'm going to tap into your algebraic skills and your basic fractional arithmetic skills. So if we multiply this out, we should get 1 times 1, which is 1. We get a negative sign of b. We get a positive sign of b. Then we have a negative times a positive, so that's a negative. But we have sine of b times sine of b. When I multiply sine of b times sine of b, well, what happens when I multiply x times x? If I multiply x times x, what do we come up with? X squared. So when I have sine of b times sine of b, that would be sine squared of b. I have 2 of them, which we write as sine squared b. Okay, once we multiply that out, we combine any types of terms that we can combine. Well, my middle terms is I have a plus sine of b and a minus sine of b. What happens to them, Gavin? They cancel out. So boom, boom, out goes those lights, leaving us with 1 minus sine squared of b. Well, if I look at what we looked at yesterday, 1 minus sine squared is equal to what? That's where if you have your sheet out and that you did some work last night and you can just sort of scan down, you should have written down 1 minus sine squared is equal to what, Zach? Cosine squared x. Well, we were dealing with the b here. And that's what we're trying to get to. So, we is done. Once again, we just followed the mathematical operations they asked us to do. If we take a look at problem number 23. Problem 23. We have the secant of A over the sine of A minus the sine of A over the cosine of A. And we want this to look like the cotangent of A. Once again, as we talked about yesterday, we relate this to the ideas in geometry in 2-column proofs. And 2-column proofs, you had to write statements, you had to write reasons. Well, everything that we have here, for the most part, is going to be substitution, so we don't have to worry about reasons. Okay, so, but we had to figure out how to get from point A to point B, though. That's you. We know where we're starting at on vacation. We know where we're going to on vacation. How do we get to where we're going to on vacation? Well, on the left-hand side, we have two fractions that are being added and subtracted, or being subtracted from each other. So if I would have 2 over 3 plus 3 over 4. I'll change that to subtraction. And I asked you to subtract those two fractions. Has absolutely nothing to do with trig class, and I can't revert to my calculator. I want you to mathematically use your 5th and 6th grade skills of mathematics. Yeah, I'm tapping into 5th and 6th grade here. And I want you to subtract 2/3 minus 3/4. How do we subtract them? What do we have to do?
Common denominator.
Get a common denominator. All right, so we're going to get a common denominator. What would be our common denominator between 3 and 4? Now, how'd you get that?
Times 4 times 3.
Yeah, the easiest way. It may not be the least common denominator. It may not be the least one, but the easiest way to find a common denominator is just multiply the two together. So I can multiply the 3 and 4 together and give me 12. Okay, so that was the first part. Have common denominator 12. In the first fraction, what are we going to do in the first fraction? Okay, then what are we going to do in the first fraction here? I have 2/3 and I want to change it to 12. I multiply it by 4. So what do we have to do here to get? Yeah, I multiplied the bottom by 4. I need to multiply the top by 4. Give me a value of 8. Second one, what are we going to multiply by, Kendall? By 3. By 3. So we have a value of 9. So let's go over here to our problem now. I have two fractions that are being subtracted together, or from each other. They're asking us to subtract them. So just like we did with 2/3 minus 3/4, we have to do with the secants and sines and cosines. So we need to get a common denominator. So Maddie, what do you think the common denominator would be here? I can't hear. What did we do to get our common denominator here? We had 2/3 and 3/4. What did you do to get the common denominator over here? What'd Sammy do? Multiply them together. So I want to do the exact same method of madness here. So what would be our common denominator? The same thing we did there, we're going to do here. We still have our secant of A on top. We still have our sine of A on top. So what are you going to have to multiply top and bottom by in the second one? Or what are you going to have to multiply the top by in your second one? Or in your first fraction, what are you going to have to multiply your top by? In the second fraction, what are you going to have to multiply your top by? Follow the same method of madness that we did here. We multiplied top and bottom by 4. Here we multiplied top and bottom by 3. Okay, so now I have sine cosine. What are we going to multiply top by? Here we have sine cosine. What are we going to multiply the top by? And once again, the only way you have of learning how to do this, you want to learn how to do trig identities, is try. And you know what? If you boof something up, you boof it up. You got it in the eraser. So Brennan, what are we going to have to multiply first fraction by top and bottom? cosine. Because I multiplied the bottom by cosine, I'm going to multiply the top by cosine. Second one, what do you multiply the top and bottom by in the second one, Gavin? Sine. So, if we take a look, in the first one, I'm multiplying secant times the cosine. I'm multiplying secant times the cosine. What would be the result if we multiply secant times the cosine?
Cosine squared A, right?
Nah, not cosine squared A, not quite yet. If I multiply secant times cosine, what would we get? Think about the relationship they are of each other. What are they of each other? They're reciprocals. So you're multiplying two things that are reciprocals. When you multiply two things that are reciprocals, what do you get? 1. So this gives us 1. Here we have the sine of A times the sine of A. So just like we had here, sine B gives us sine squared of B. You get the same thing over there. So we have sine squared of A. So once we did our multiplication, what do we do to subtract fractions? We subtract the top and keep the bottom the same. We go 8 minus 9, all over 12. So let's rewrite this. Well, we can't really do anything with that, but I can rewrite it as 1 minus sine squared of A, just like we write 8 minus 9. So on top we have 1 minus sine squared of A, which now we're going to tap into what Gavin wanted to tap into. If I have 1 minus sine squared of A, that is equal to what? 1 minus sine squared equal to cosine squared. Bless you. Are we there yet? Are we there yet? No, because we don't have cotangent there. But I've been able to do some manipulation here. So we go into the next little, let's see, little magic trick that we can pull out of the bag. Throw some pixie dust on this thing and see what we can have. Tinkerbell comes out. Speaking of Tinkerbell. Boom. Now, once again, I'm going to tap into your math skills from 5th and 6th grade. You have the fraction 25 over 6. Okay? I want you to write 25 over 6 equal 2 fractions that are being multiplied together. I want you to rewrite 25 over 6 as 2 fractions being multiplied together. Neither of the numerators can equal 1, or denominators can equal 1. So none of the numerators and denominators can equal 1. So I want you to rewrite 25 over 6 as 2 fractions that you can multiply together. Neither the numerators or denominators can equal value of 1. Two fractions you can multiply together. Neither fraction can have a 1 anywhere. Chloe, what do you have? 5 over 2, 5 over 3. Because I have to multiply my tops, I have to multiply my bottoms. Let's do the same method of madness. I want you to rewrite cosine squared, which is, once again, by definition, cosine A times the cosine of A. Rewrite it as two fractions that you can multiply together. Neither of the numerator or denominators can equal a value of 1. Can't have a 1 anywhere. Just like we went 25 is 5 times 5, and 6 was 2 times 3. How can you rewrite cosine squared over sine times cosine as fractions? None of the numerators or denominators can equal a value of 1.
Okay. I'm trying to slow everybody else's brain down.
So Owen, what do you have? All right, well, I'm trying to slow everybody's. I know there's different ways. Like I said, you're in Dalton, Worcester's over there. You can get from Dalton to Worcester an infinite number of ways. What I'm doing is I'm going in a direction that hopefully is the easiest for people to see and slow their brain down enough. Because I know there's algebraic skills that we could use, and I'll go through that here in a second. But I'm just trying to slow everybody's brain down so you can see what is happening here. Rachel, what do we have? Huh? Well, let's see. 25, you went to 5 and 5. Because 5 times 5 is 25. Well, on top we have cosine squared, which is cosine cosine. So what can we put in both the tops? Huh? Cosine. On the bottom, I got sine times cosine. Over here, we had 6. So we went 2 times 3. Why did we go 2 times 3? Because 2 times 3 was equal to 6. So here I got sine A times a cosine A. So what can I put in each one of the bottom? What can I put in the bottom? Sine and cosine. Just like we did over there. Now, let's take a look at my second fraction. We have cosine divided by cosine, which is 1. Here we have cosine over sine, which is, by definition, cotangent A. We is done. Once again, I know there's different methods of madness to get there. I'm just trying to slow our brain down. I know if you had x squared over x times y, I can cancel that out and that out. Give me x over y. Here I could take, I have cosine squared, and I have a cosine, sine cosine. I could cancel that out with that. I understand that. I'm just slowing it down so we can hopefully make some connections here. Something like that is something like I'd like to put on tests, right there. Because that taps into algebraic skills, that taps into 5th and 6th grade mathematics with respect to fractions. If you want to learn and get better at doing trig identities, redo that problem and try not peek into what we just did. Try not going, and if you need to peek, okay, slide it over, what do I do next? And then go to it. But redo the problem. That's how you get better doing trig identities. I had a math class in college. It was called Concepts of Geometry. That geometry class you took, okay, you went through that geometry class you took for the first 4 weeks of the class. Then you went through what was called non-Euclid geometry, which was blow your brain type of geometry. The professor, Dr. Welch's favorite professor, Dr. Raber, he started out legal size sheet of paper. Didn't have computers back then, so we wrote out every problem. He started out with 30 true and false questions on the front page of a legal size piece of paper. 30 true and false questions. He then went to backside, front side, backside, front side, backside, all dealing with proofs. Oh my gosh. I thought I knew geometry. I thought I was pretty good. I was cocky. I got this. I walked in there. I thought this is going to be easy. I understand geometry. I got a C on my first test. I went, oh, ouch, that one hurt. Okay. And then it got hard at that point. And basically, he had test banks that you could go buy. And from those test banks that he would take about 5 of the 6 proofs off those old test banks. I would go and just redo problem after problem after problem. I'd sit in Bryce Hall up there, which was a library, and just redid problem after problem after problem. And once I did it once, I would do it over again, and I learned how to do proofs. That's what you have here. Okay. Now, as we go through this, the first day, once again, is very fast. Okay? Going through a couple problems here. Hopefully it slows you down a little bit. Okay, gives you some ideas to work with. Okay, we will spend 2 more days, tomorrow and Wednesday, or today and tomorrow, dealing with trig identities. Then we're going to move on. Okay? I learned once we get through past day 3, it's not going to increase our understanding level anymore if we just keep on belaboring more and more days of it. So we move on. Okay? But once again, you need to put the effort forth. You have page 116, 117, 3 to 33, multiples of 3. We will once again come in, we'll go over a few of my favorite problems. Okay, my favorite problems, and that's not saying no more, are problems that you tend to see again. Okay, this problem, I like this problem. There's a good chance you'll see something like this again somewhere along the line. Okay, so being able to redo this problem helps you out in regards to processes of trig identities. All right, questions. Keep working at it. It gets better.